Welcome to our webinar, Reconceptualizing Computational Thinking, from Computer Science to Information Science, stemming from our Institute of Museum and Library Services funded grant, a national forum on integrating computational thinking into LIS Youth Services courses. This forum, related resources, and webinar were collaboratively developed by Dr. Joe Sanchez, who is an Associate Professor at Queens College, Marika Visser, former Senior Policy Advocate in the Public Policy and Advocacy Office at the American Library Association, and me, Dr. Jennifer Moore, an Associate Professor at the University of North Texas. Thank you for joining us. The purpose of this webinar is to define computational thinking, to explain the National Forum's purpose and process, to explain the outcomes of the forum that include modules for you to use in your library, and to provide related resources. Our National Forum had 4 goals. Extend the current understanding of CT by inviting faculty scholars from outside of computer science who are teaching and researching in the areas of CT to work with LS faculty to create class activities or modules to further develop CT as a critical literacy. Connect faculty with projects and resources completed by school and public librarians to demonstrate how they have uniquely interpreted CT for use with their youth communities. Include fresh voices in the CT conversation by inviting pre-service and in-service librarians to discuss ways of embedding the concept into library programs for youth. Broaden the community of practice formed through the Ready to Code program by disseminating the resources created through the forum to improve the research practice continuum. Why did we develop this national forum? To address existing gaps in LIS research. To align LIS coursework with standards and competencies identifying computational thinking as a needed skill. To extend the library's Ready to Code initiative identifying needs for pre-service librarians to develop skills to embed LIS-specific CT skills and activities in youth programs. Support for LIS faculty to develop CT activities. Opportunity for interdisciplinary faculty cohort to offer insight and inform LIS practice. Exploring CT as a literacy applicable to LIS. Resource creation for in-service school and public librarians, increasing youth access to CT, especially for underrepresented populations. What is computational thinking? Multiple definitions exist, each with its own subtle nuances, and the intricacies of the definition depend upon the entity writing the definition. CT's foundation is in computer science, and a frequently cited definition was developed by Jeanette Wing. She defines CT as the thought processes involved in formulating problems and their solutions so that the solutions are represented in a form that can effectively be carried out by an information processing agent. I define it for my school librarian certification students as an ordered or systematic problem-solving process that is transferable from computer science and K-12 education into other facets of our lives, including college, career, and everyday life issues. A former student extended my definition by adding, computational thinking involves taking a large-scale problem and breaking it down into smaller components to make it more manageable. These components are then organized and further analyzed to help create a solution. CT involves multiple concepts. First, a problem must be identified. Decomposition, breaking down data, processes, or problems into smaller, manageable parts. Pattern recognition, observing patterns, trends, and regularities in data. Algorithm design, developing the step-by-step instructions for solving this and similar problems. Abstraction, identifying the general principles that generate these patterns by focusing on the important information only, ignoring irrelevant details. There are, of course, variations in the process depending on who is defining CT, but for the sake of simplicity, we're going to focus on this variation. Our National Forum consisted of 5 phases with 2 workshops, with the intent on blending library and information science and computational thinking, reconceptualizing the concept to focus on community, humans, learning, information, design, and literacy. The first workshop involved a cohort of interdisciplinary faculty, and the second workshop involved in-service and pre-service school and youth librarians. The Faculty Participatory Design Workshop consisted of two phases, the pre-workshop concept development and the Participatory Design Workshop. For the pre-workshop concept development, 10 faculty members from Educational Technology, Learning Sciences, and LIS, one representative from Google, one representative from Microsoft, and the project team met virtually for 90 minutes in fall 2019 to discuss CT from an interdisciplinary perspective. What does CT mean to them, and what does it look like in their research? In January 2020, the group met at ALA Midwinter in Philadelphia for a day-long session where we collaboratively developed drafts for activities and modules that were focused but also adaptable to multiple age levels. We will explore these modules later in this presentation. The in-service and pre-service School and Youth Librarian Participatory Design Workshop also consisted of two phases, the pre-workshop concept development and the Participatory Design Workshop. In May 2021, 10 pre-service librarians focusing on school and public youth and 10 practicing librarians focusing on school and public youth with varying levels of knowledge about CT met for a 90-minute virtual session to discuss the purpose of the project, ways that CT is being recontextualized for LIS, and expectations for the workshop sessions. The participants were then divided into 3 groups, with each group scheduled to meet once for a 3-hour session in June 2020. Each participant group tested one module, acting as if they were learners, and then providing feedback so the project team could refine the modules for dissemination. For lesson plans and detailed videos for each module, visit our website. A link to the website will be shared at the conclusion of this webinar. That was the process for recontextualizing CT. Instead of focusing on computing and efficiency, we focused on integrating community, humans, learning, information, design, and literacy with CT. Now let's briefly explore these modules. Lesson plans and instructional videos for these modules can be found on our website, which will be shared at the conclusion of this webinar. The first module focuses on computational thinking within the context of storytelling. The goal of this lesson is to create a cohesive story using disconnected pieces, or blocks, that demonstrates the use of sequencing, conditional logic, and pattern recognition, key concepts under algorithmic thinking. Module 1 Objectives. The learners will be able to create a story that demonstrates the use of sequencing, conditional logic, and pattern recognition, key concepts under algorithmic thinking. Articulate the CT concepts in their own words. Identify the concepts of sequencing, conditional logic, and pattern recognition in another person's story. Manipulate variables. Articulate their story paths. Reflect on the process, going through the debugging process. What do the CT concepts look like within this context? Problem statement. Creating a cohesive story using disconnected pieces or blocks. Decomposition. Break the story into manageable pieces. Pattern recognition. The patterns are identified within the story circle. Algorithm design. Follow the path of the story circle, adding conditional statements and loops. Abstraction. Ability to create your own story or evaluate existing works using a model. For this lesson, we provided story building blocks, but of course you will modify the words on each block based on your learner's needs and the context of the lesson. Your learners will create a flowchart with multiple story paths using the story building blocks. You can use a program such as Jamboard for a digital activity or sticky notes for a non-tech activity. Construct a story following the steps of the story circle using the previous flowchart as a guide. Variations are okay. Identify the protagonist, setting, conflict, and resolution in your story. Include a conditional statement in your story. Include at least one loop in your story. Debug your story to fix any plot holes. Here is an example of story building blocks. We used Jamboard, but you could also use sticky notes. Wildcards were included for learners to substitute words or ideas as needed. Here is an example of the finished product. Your learners will manipulate the variables or the story building blocks, placing them in the corresponding locations, and then add additional details using self-created and different colored story building blocks. Learners used the fundamentals of CT, decomposition, sequencing, conditional logic, algorithms, abstraction, and debugging to develop a cohesive story. Think of this within the context of basic literacy. For additional details on teaching this lesson, please visit our website, which will be shared at the conclusion of this webinar. Module 2 focuses on patterns and beauty, with the goal of being to understand the patterns of contemporary beauty as expressed in social media by influencers or for younger learners in picture books. Module 2 objectives include: create a face to decipher the CT concept of decomposition and sequencing, identify the concepts of sequencing and pattern recognition in another person's picture, reflect on the process, going through the debugging process. There are 2 activities in Module 2. The first activity involves watching a video on how to draw a face using basic shapes. The learners then draw a face that shows emotion to decipher the CT concepts of decomposition and sequencing. A face has sequences. There are variations, but the forehead is on the top and the chin is on the bottom. What do the CT concepts look like within this context? Your problem is drawing a face. You decompose the parts of the face, such as eyes, nose, and mouth, which are standard parts of a face. In the video, the artist used patterns working in halves and also used basic shapes. You may have noticed how the artist kept having half of this, half of that. Using an algorithm, the artist and your learners will repeat the shapes and halves. Specific details like hair and shading were omitted, ignoring specific details because everyone's face is slightly different. Instead, the focus was on creating an outline and positioning shapes, or an abstraction. The second activity in Module 2 has 2 parts. The first requires learners to analyze social media profiles, or illustrations in picture books, to identify the patterns of beauty expressed, focusing on lighting, color scheme, angles, and posture. They then looked for ways to improve photos of people who are not influencers. Think of this within the context of both visual and digital literacy. What do the CT concepts look like within this context? Problem statement: how to improve a photo. Decomposition: examine lighting, background, body position, angle, proportion, color composition, and facial expression. Pattern recognition: the subject is rarely in the center of the picture, the subject rarely looks directly at the camera, the lighting is natural, the background is well lit, someone else holds the camera, the colors are competing or complementing, bright and cool, and the influencer presents an image of something for the viewer to aspire to. Algorithm design: choose a purpose, establish mood, and/or an intended reaction. Sequence to choose purpose: how to get people to choose a purpose. Who is the audience? What would the photographic subject like to convey? What does the photographic subject want people to do after interacting with the picture? Abstraction: choose a focal point, consider the various types of balance that must occur, and be aware of the implied narrative. Again, after analyzing social media influencer photographs, the learners would then use these concepts to improve photos of people who are not social media influencers, applying these patterns found in beauty. Thank you for attending the webinar. If you have questions or comments, feel free to contact Dr. Joe Sanchez and/or Dr. Jennifer Moore. For complete lesson plans and instructional videos for the 2 modules, please visit our website.